There's like sitting minutes for the wrong side.
Yeah, I biked too, but I was like, 'cause I had some time to draw. Well, I had like a lab meeting at like 8 a.m. So I've been here. Yeah. No, it's real. I'm not really like it's pretty good.
By the way, okay, I'm drunk, so no.
Are you feeling?
That's good.
Do you live on Seventh or? I think we're neighbors. I seen you. I seen you biking the other day. I was like really confused because I saw you biking. And I was like, is that what you're on?
Yeah, that's where I live.
Yeah.
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 Yeah, gotta move now.
I was also like, I was like driving and just seeing you know, it's just very like, I was caught off guard.
Right.
Yeah.
Then you start following.
Yeah.
That's when you know exactly what to do with it.
Okay, I have to like watch myself.
Yeah. I won't throw parties, like loud parties. Live in like the square, like haunted looking house, like with the banana trees in the front.
Oh, no way.
Yeah.
Okay. Yeah. Great.
There's
Okay,
like,
anything that you see happening at my house, just you keep it to yourself.
I will.
Okay. Yeah. I was out the other day, there's like a bunch of old poison ivy growing up, like pine tree, it's like
Mhm.
20 years.
Have you seen like the power line where there's like in the summer there was grapes growing and hanging off of the power
Oh,
line?
nice.
Like, and they were like, it was like the whole thing was like sagging. I was like, this is like a disaster waiting to happen.
It's scary.
It's an old street.
It's old street, like, I was like, how do you not cut these poison ivy vines for 25 years? Like, so I was out there a little bit too stoned maybe with my machete, like hacking at this thing, and my wife's like, we just moved here. You gotta like, gotta let the neighbors. Like,
Yeah.
okay.
Is your house really old too? Mine's like
1960, I think.
Mine was from the 40s.
I like the food and drink. It was like I like write my phone words first, so they like had to like restore it and stuff.
That's
So
nice.
like I'm from Ohio, but I found like a from like 1920 of like all the like houses in Williamsburg, like my house would have found that like that.
That's
It's
pretty
just, like,
cool.
so fun. Yeah. Yeah, but apparently when they my like grandparents and like when he bought it and was doing all that, they found like a bunch of like artifacts and stuff that they like gave. So like
You know, like Rob or Lauren, like Rob,
oh yeah, yeah.
or like, I know from Ohio, like Lauren.
I don't know her, but I know her. He's from
Okay. I am going to connect to the VPN and log into the HPC. Do my alias. think more or less from here on out, the bulk of our work will be done in the HPC. This makes sure that we all have the same files in the same spot. Half of us aren't having .zshrc, we all have that home .rc. So again, I can look around and I see in my home, as soon as I log in, there's my .rc. We will be modifying this file here and there forever. Today, one of the things that we're going to do is modify our path variable. If you remember last time, the path, how do I show what my path variable is? The muscle memory, echo $path. Okay. And what is all that stuff?
Those are the different paths in the suitcase,
Yeah. So exactly, those are the different paths that my computer searches by default. When I type in some name of a thing, whatever it is, like ls or echo or whatever. You know your computer is actually really stupid. It does not know what ls means. There's no concept of that, but it knows to look for a file called ls in one of these locations, starting at the first one, then colon, and the second one. And it looks for something called ls. If it can't find it, it says no file. So I'll try lk. Command not found. That means it searched all those locations and found nothing called lk. But ls, it found it in there. And then that's just a bunch of ones and zeros, an executable file. Today, we're going to start making our own little scripts, our own executable little programs. So stuff like ls, although ls isn't written in bash, we're going to be writing our stuff in bash for the most part. If you have experience with Python or R or C++ or whatever, you can write in those, call them from the command line also. We're going to get into a little bit of bash scripting because that's how we will very often be working with all these genomic files that we get. Little housekeeping, don't forget, next class period is our quiz and assignment 3 is due. And then before we start scripting, that's lesson 4 in your Google Drive, we should probably do a little review and practice some concepts, in particular this one and this one. What are they? Process and command substitution. Arthi knocking it out of the park. Okay, what do they do? We only got to kind of glance at them really last time. What's that? The actual date, right? So that process substitution there, it's going to evaluate what's inside of the parentheses. There just so happens to be a command in bash called date. If you run date, it'll find it in your path and it spits out this stuff. Okay. The date by itself gives me that, but I'm using it in a drop-in capacity. So we can always do that. We can have it evaluate a little chunk of code that we want to run, feed it into some other program this way. And then what's this one? What if I try this? I'll just go up here and switch that out. Imaginary file. Yes. So this is an imaginary process. Well, not imaginary. It actually happens, but it's like a vanishing process. It's like doesn't live anywhere permanently. This is a vanishing file. Okay, so cat works on files, right? You give cat a file name and it spits out the contents.
So how long can you like access the file and like date?
That's during that process. That's it.
Okay, so like if you did it again, you would maybe.
The date will change, right? Because it's time has been moving. But
So it's like just in the line you're calling it. I don't-
Mhm.
So like what's just sitting next to you is like, oh, I'd go with that, like it wouldn't.
Maybe I misunderstand the question.
Yeah, so like there's like the file date that was like created in that line. So like could you
Oh.
never like access it again, like it's only in that
Yeah,
line, like there's.
the file itself is not even called date.
Okay.
Wait, we don't want to echo. We want, so like paste works by pasting files together as if they're columns. Okay, so we can paste the file date to nothing. Okay, that file itself, I wonder if which will work. Yeah. No 63 and dev fd. This file is not called date, it's actually called dev fd 63. Root dev fd 63. It's just a temporary spot. And it like doesn't exist outside of the process. So like while it's being called, it exists, and then instantly afterward, it's gone. So it's a temporary imaginary file. We have both of these where we can have like a temporary process and a temporary file, because some programs don't want standard input, they want a file. Pasterly wants to work with files. So let's see. I'm going to go into biocomputing. And go into resources and practice. Exercises. Okay. Just a little sandbox, a little spot for me to mess around. And I'm gonna make two files using Nano. I'll call this one file one. And I'm just gonna do ABC and save it. And on Nano file two. And I'll do 1, 2, 3. Save it. Then I'm gonna cat file star, which will do what? That's the wild card.
Adding anything that starts with file.
Anything that starts with file and then has 0 or infinity of whatever afterwards. So it should concatenate file 1 and file 2. We'll stick them together. ABC 1, 2, 3. in the order that I found them. Okay, so I've got my two files. But I can stick them together with paste. This is just the opposite of cut. Remember, cut turns things into columns unless you pick columns. Paste. File 1 and file 2. The cat sticks files head to tail right after each other. See, ABC 1, 2, 3. Line by line, concatenates any amount of files together. Paste sticks files together, but it does it column-wise. So this is kind of a lot of work. If I wanted ABC in one column and 1, 2, 3 in a second column, I went in and had to make two files and then paste them together. I like this stuff. How do I? Trying to get them to line. We'll stick it here for now. Echo 1, it's trying to illustrate the concept. Put them in quotes to be a good person. What does this command? Behind the scenes, what's happening? When I run it, I get 1 and 2.
It's like running the echo command twice, and then it's paste, you write and pasting out both those outputs,
What are those outputs?
1 and 2.
Where? They're imaginary files. Yeah. So I'm pasting together two files, but those files don't actually have to exist. Why is this important? Why not just make the files stick together?
Like a waste of space sometimes.
Big old waste of space. And in computing, the slowest bottleneck always for like literally taking more time to compute is when you're writing and reading from disk, especially that like hard disk, that storage, that long-term storage. Writing to disk takes forever. I mean, full milliseconds, right? That means a lot if you've got 10 million lines. Writing those to disk will slow you down by 20 minutes for that little operation versus having that process kind of just running in imaginary space. It evaluates that. It never has to write it to disk. So temporary files. So these actually come in handy and they can speed up our code quite significant by like hours and start working with bigger files. Okay, so process and command substitution. Okay. Yes.
Minor probably, but I'm like stuck in control excellencies.
For
Like it just, I hit enter before I hit, like before I finish my quote.
Control C. Control C is stop the process. Sorry. Yeah, that's all good. Control Z is a different thing we haven't dealt with yet. Okay. All right, well, how are we feeling about process command substitution, everything so far all semester? Now's a good time to check in because we're about to start writing scripts. Who did the practice stuff? How did it go?
Those are okay.
Okay,
I have a question for the second one with be bigger than some, is that's command substitution?
command.
So for,
I always get it mixed up.
yeah, for echo, like, when you're just, if you just said echo and then in no quotes, command, then eight. Is this echo, that wouldn't work for echo because it just
Echo,
doesn't like files, it wants text?
yeah, Echo wants so like, look here, I've got a file called file1. If I say echo file1, it seriously, it just takes that literally. So Echo wants some standard input and it doesn't know how to use a file for standard input. Okay. And so if I say echo and then process at file1. All right, what's happening here is I'm gonna barf up the content to file1, feed that to echo as the standard input. I get my APSC. I want the oops. Run. I want to go in and practice exercises. Units tools part 1. And let's just take a look at these. Here's a zipped directory. I'm going to right click this, copy the link URL, and show you a trick you may have found already, but maybe not. wget and then paste in that. That'll get anything from the internet. You got a URL, it will just download it for you and stick it right there. wget. Very handy. The Windows version of like Git Bash doesn't have wget. Mac doesn't come with it automatically, but all Linux does. And so here we are in the APSC that wget. It got this little file for me. And I'm going to start keeping track of these commands. So there's my wget. I'm going to turn this into a little script here in a second. How do I unzip this thing? Not gunzip. Gunzip is for gzipped files. This is just a regular zip. So it's even easier. Unzip. Capital CH tab. Cool, it's unzipped it. I'm happy with that. I'm going to copy this. And then paste it in here. So I'm just keeping track of my stuff. Download the file. Making little comments here. Unzip file. Okay. Now I look around and it gave me this directory. I'm gonna CD into that directory. Better write this, CD into that directory. Look around, I've got A, B story versions. Excellent. Okay. Following me so far? You don't have trouble with any of those steps.
No, so we're just like in the practice files directly.
Yeah, I'm just, you can stick this wherever you want. I'm gonna wind up deleting this and only saving the script that I write. Show you that. Okay, so we've got the practice files, we've downloaded them, we unzipped them. That gave us this directory, we entered the directory, now we've got our 4 files that were mentioned here. So here's a zip directory, download and unzip it into some reasonable spot. Use those files to accomplish this. All right, combine the contents of a.txt and b.txt to a new tab separated file called c.txt. Okay, you guys just saw this. How do I do it? I'm going to use paste A and B, and then what? Redirect the standard output to c.txt. Easy. Cat the contents of that, sanity check. Oh, I am happy. I am doing things on a high performance computer. This is scientific computing. I stuck A and B together. Yay. Well, I like that, man. It worked. So I'm going to save it. Stick it over here. I'll say task 1. Done.
So
Okay.
everything dumped isolate is like the tab separated file, or like you don't have to specify anything.
To get it to be tab separated,
Yeah.
Paste does that on its
Is it
own.
automatically?
Yeah, so by default.
So could you make like how you use these to make it a comma separated file or something?
Just like this.
Oh, cool.
I think I have to move the D before I give it the file, so. No, okay. It was fine with that. You can tell it what the delimiter is. Just like with cut, you tell it what the delimiter is.
Okay, yeah.
Paste, yeah, so we can make things into comma separated files, no problem. How would I discover all the fun tricks that I can do with paste? Dash help. All right, so we can give it delimiters. Paste one file at a time instead of in parallel. That's pretty much it. So that worked. We got our c.txt. Next up, task 2. Combine the words that begin with either B or E, case insensitive, from words.txt with the first 6 lines of the c.txt we just created. All right, it's early and I know it's like rainy out there and you all just want to curl up with kitty cat in bed. Well, talk me through this.
Would be easier if you like started like just getting the first 6 lines C and just piping that to something else.
So we need the first 6 lines to see how do we get that.
Just do like head and dash six or cat and dash six.
So that's how I get my first 6 lines. Okay, that's 1/3 of the problem. Another third is we need the words that begin with either B or E. So if I cat words.txt, I can see it's some words. Some of them start with B, some start with E, capitalized or not. How do I do that? Correct. You're on it this morning. But correct what? Case insensitive is an I. And then I need to tell it what file. Yeah. Damn.
What is that?
You're like, wait, what did that do? grep global regular expression patterns, so we can feed it this regular expression type pattern matching stuff.
Yeah.
It finds lines in any file or any fake file or any standard input or whatever that have that pattern. We said -I for case insensitive. Don't pay attention to capital versus lowercase. And then I said it starts with a B or an E. Now, if you can't come up with that pattern on the fly, you need to practice this more, because this is the sort of thing that you're going to be using a lot. You do not want to have to be Googling this every time. Trust me, I am a big fan and will tell you when it's best to use GPT or Google. This ain't one of those times. This is learn this. Okay? You're going to use it all the time. That first starts with, very important, and then the ends with, which is what symbol.
Is it-
away. A star. There we go. Starts with B or E, and then any character, any amount of times, and then N, and then end of line, $sign. Only one line met those criteria is button. All right, so here's our pattern we want. Cool. Okay, so this is working. I'm happy with that. Yeah. The dot means any character, any single character. And so it's like, that's saying starts with B or E, and then any character, and then the star is like 0 through infinity. So it's like any character 0 through infinity times, and then an N.
So it's almost like the dot stars like kind of doing those, like the middle doesn't matter. Just like
Middle doesn't matter.
And then
That's,
the-
yeah, and that is such a common pattern, is middle doesn't matter.
Okay.
So this comes up a lot in bioinformatics. You'll have a big string of nucleotides, and you're looking for ones that start with a certain pattern because that's like a primer set that you were using or something. Middle doesn't matter, and then you're looking for the ending of that. So a lot of algorithms have this kind of like middle doesn't matter thing going on.
So you could use this to essentially upstream forward and reverse patterns, and then you go on that,
Yeah. So we could search for, and grep is kind of nice because when you use the -F, you can search from a file. So you could have a list of primers and say, search this whole thing for any of these 8 primers I'm looking for. It happens in milliseconds. I know we're starting with like these really dumb files that just have the word eggplant in them and stuff, but like, it's because it's easier to kind of learn how to deal with patterns and all this. When we get to real genetic data, you're going to feel a lot more comfortable because you've done it with the word balloon. And DNA data is just the word balloon written in biology. Okay, so I think we're like there pretty much. We know how to get this part, this column, and that was the head 6. We know how to get this column, and that was the grep. So let's stick them together. This one made me happy. I'm gonna save it for now. And then if I go up, 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 where's the one that, aha. This command made me happy. I'm gonna save that one as well. Now, how do I paste them together?
Command substitution for the dollars number.
I'm gonna wrap them each. Yeah, so now I'm turning those outputs into fake little files. And I'm gonna copy that. Cut it. That makes sense? So I'll copy, paste it in here. That a little smaller so you can see it all in one spot. I'm creating exactly the output I want from those files using head and grep. Pretending they're their own files and pasting them together. Thoughts, concerns, questions?
For the, when you did the ends with pen, why did you do a dollar sign at the end of the line?
Dollar sign means end of line,
Okay,
just like the up caret means beginning of line.
and then the dot, the star before just means anything before it, right? The dot star.
Any one character, any number of times,
Okay,
including 0 times.
okay.
Okay. How about task 3? Return the first 6 sentences from story.txt. Add story.txt. Sophie could feel the giant's feet pounding once again. This is a story about you, Sophie. Now it's Roald Dahl's Big Friend the Giant, but how do I get the first 6 sentences? Head and 6 story.txt. Nope, that gives us the whole damn thing. Word count, the number of lines in story.txt. There's just one line.
So where did you make it?
Okay. Period separated. So sentences are ending with a period, or maybe a question mark.
Um,
In this case, no. So let's stick with period. But keep in mind that if you're looking for a specific gene, you guys have had bio, right? Like, you know what a stop and start codon are. You know that they can be a bit different. And so you need to think about, like, what does the ending of a gene really look like? It could be a few different things. Same here. This could be ended with a question mark, an exclamation, period. In this case, they're all periods, so we'll keep it simple. So how do I split it up based on a period? Cut. Give it the delimiter period. And then how do you must specify a list of bytes, characters, or fields. So what fields do I want? 1 through 6?
That was just like.
Fields. Which column you want? Got it. So if I just wanted columns 1 and 2, there they are.
So it's considered each sentence as a.
It's cutting anything you give it on any single character, and we said cut it on a period. And it cuts there and makes columns, and so
That's how.
that's how it knows, and then we say, hey, give me fields 1 and 2, fields, columns.
Okay.
So it like doesn't return it as columns, so it returns it as just like the first point, like the first sentence really. Like. I don't know.
What's it returning it as,
Yeah,
in other words? Just exactly the way it looked after it cut it from.
so it almost like goes back to.
So it looks at your file, finds that character and starts splitting it. And it knows how to pick the parts, but then it'll just give it back to you the way that it was in the file.
So we could also do like 1, 4, 7, like skip around.
You can skip around and you could say 6, 3, and 1. And it will return it in that order.
So when it return it like 1, 3, 6, you return 6, 3, 1.
It'll return it in the order you tell it. Yeah. Which can be handy. Well, that one's a bit too easy, but okay. Here's how it worked. I'm gonna save that. Over here, my little running document. This was task 3, this was task 2.
Is there else really say 1, 3, 6?
No, cut wants it to be comma.
So you can
Separated.
do the-
You can't do the little brackets. No, Bash understands the brackets, but cut program doesn't.
So what if you wanted to like split it by like periods or question marks or exclamation marks? If we should just do like period, comma,
I wouldn't use cut.
we would just. Okay.
Because cut really just wants you to tell it, here is the thing, split it on.
Like,
I-
period space, and then cut only on period space.
It's a single character. Cuts, I mean, all of these programs, remember, they're really stupid and limited. And they do one thing really well and really fast. Cut wants a single character. But there are other programs that can take 2 characters and translate them into a single one, and then feed that cut. So I could cat my story. Don't follow along with this. Like this. I could type it to this little program where I search for period space, replace it with an underscore globally. Oh, I mean, literally a period space. There we go. So anytime I found a period space, got an underscore, and then I pipe that to cut where I'd say find the limiter, it's an underscore, and then one of fields. 6. So that's how you would do it. Little programs working together with the pipe. Okay. Yes.
When you should really nodes like use like type versus just like the process substitution, when is like a better time to use it? And there's like only like when there's like programs that like prefer files versus ones that just prefer just like output. Is that like the main?
Yeah, so the reason we're learning about process substitution in the fake files now, it has not actually been necessary for anything we've done, but it will be when you start seeing some of these bioinformatic tools that people have written. They want like, what's your input file? What's your forward read file? What's your reverse read? You're just feeding it variables that calculate that for you.
Yeah.
Okay, let's try this one. Task 4, return the first 6 sentences from story, 1 per line, and then combine that with the first 6 lines of a.txt. I was always think through in your head in like plain language. The sorts of steps that could get you to this point. I know that one of the things would be, just like we did before, add n6 of a.txt. A, turn that story into one sentence per line. And have ideas how we can do that, like, and don't give me bash commands, tell me like ideas of plain language.
You could go from like every period and then you use a command to give it like every like in the before period, the next period.
Okay, so we use those periods again. And instead of cutting on them and splitting them up that way, what do you mean? You'd like
I
to,
was saying like if you could you use like breadth and like say like if this thing certain amount of characters and then ends with period and then split it onto the based on that to just like it gives you row by row.
yeah, right now we just have one line. Right, that's all on one line. So if we want to get it on multiple. The cut command did what for us? It split it into columns based on the period. Really, all we need to do now is say like, hey, every time you see a period, make a new line.
Mm.
Easy. You guys know how to do that one. I'm gonna cap my story and I'm gonna pipe it to TR, which is what? Translate. So what? I'm gonna translate period into what? What's the special for new line? Backslash. Parrots, the pattern matching for line starts with. Translate period into new line. Ah, beautiful. That was just too easy. Okay, I'm gonna take that, copy it, stick it over here, and I know it's gonna be its own little file, little fake file. Paste those together. Oh, so close. Not quite the output we were looking for. Here's what we wanted. Just the first 6 sentences. Okay. How can we modify a little command here? Yes. I do that inside of my process substitution. So the imaginary file and paste together is the standard out of padding story. Pipe to translate, where we're replacing periods with new lines. Pipe to head in, where we're just taking the first 6 of those. And oh, it's beautiful. Okay, so this is what I'm happy with. Copy. Paste it. Okay, those 4 tasks. The rest of this is just like test your knowledge stuff. Okay. I've been keeping track of it as I go along, but it looks to me like these are all of the commands in order to accomplish everything for that whole like set of 4 tasks, including getting the files, unzipping it, going in there, and then doing the 4 tasks. So you almost have written script at this point. The only thing you need to do is let Bash know this is a script. And there's a magical way of doing that. And it will bring me to lesson 4 here. We're talking about scripts. So we got a little table of all the components you need. But this is a nice little script example for you. That first line is the interpreter line. Tells your computer how to interpret the following commands. In this case, what are we saying? Language is bash, and by the way, computer, you don't even know what the language bash is. We've got instructions for you, and they're found here at root bin bash. That first little hashtag exclamation is called the shebang. That's pretty fun. And it's always going to be the first line of any of your scripts. If it's a Python script, it'll be shebang in Python 3. So that's all I need to do up here. It's on line 1, shebang, \bins, \bash. Ta-da! That does not get interpreted as a comment. All the other hashtags you see denote everything to the right is a comment. So Bash will ignore them, but it does not ignore that first one.
Is that because of the definition? Or like why? Like how is
It's
it?
because of it's in the very first top left spot, and it's got the destination. Yeah. So if you put this anywhere else, it's gonna work.
Okay.
Yeah. So if I highlight all of that, copy it, come to my terminal, and remember I'm in my like practice files that I downloaded. I want to get out of those, so I'm gonna go back one, just in my practice exercises, and I'm gonna make myself a new file. Nano, I don't know, what should we call this thing? Do stuff. And I'm gonna give it a .sh extension, just for me and other people to know that this is a shell script. Then I'm gonna paste in everything. Just keep a track of. Shebang bin bash, and the downloading, the unzipping, going in and doing all those tasks. Cool. Paste it in, Control O to save it, Control X to exit. I look around, there's do stuff.sh. And I'm gonna remove recursively chapter 3 practice files star. That's gonna get rid of my zip and the practice files folder that I unzipped. They're gone. I'm gonna go ahead and clean up by removing file star and test file as well. Let's get nice clean. Okay, we've got ourselves supposedly a bash script that should do those first 4 tasks automatically. So do stuff.sh, man not found. Good.
show it where with the dot stuff.
Okay, I could dot slash. Do stuff dot sh. Permission denied. I did have to say where it was, how come? Because it's not in my path. So when I tried it without the here, it said command not found, that's not your path. We could move this file to one of those path locations. So you probably can't because it's not your computer, it's the agency. But now it's saying permission denied. LL. Here's my permissions.
It's not exactly where.
Need that X. I can read and write it, but not execute. So what's my change?
chmod plus X.
Chmod. We're gonna modify our permissions. Plus X means add executing privileges to everybody. Do stuff dot check. Since we're the owner, we get to do that to this file. I look around, I'm happy. Go ahead. And change the color for me,
Why is it having?
because it's a program executable. Yeah. So now I can dot slash do stuff dot sh. And I do have to tell it where it is. If I just say do stuff dot show, it's gonna say command not found. It's not in our path. Enter. It's done. There's all my tasks. It downloaded everything. Did it all. That's just cool. Okay. It left a mess behind now. So I'm gonna nano do stuff again, and then down here at the bottom, I'm gonna say clean up your trash. Remove R that star. Save this, exit. Move. Okay, do stuff.sh. Again, I'm gonna try it. Runs it. Cannot remove chapter 3 practice file star sh file or directory. Ooh, I think I know why. You can figure out why. That means you understand file paths.
Doesn't know where that is. You can give it like a dot or the location before that. If you're looking for the like it's looking for like the chapter 3 practice files within chapter 3 practice files.
Yeah, we did CD chapter 3 practice files, and it's never gonna be able to remove something that isn't inside of there. Okay, so what do we need to do?
You do it up for you.
I wouldn't do you because that depends on an alias.
Okay, so cd dot
CD dot dot. So nano do stuff. CD dot dot. I'm gonna do this all in one line just to show you that you can. Semicolon means new command. It's the same as hitting enter. Cambridge trash. Go back one and then remove check the practice file. Okay. Okay. Do stuff. It did it again and cleaned up after itself.
Could you open the mirror? I would use.
All right. I'm gonna just say CD, hit enter, I'm on home. And I want all of you to make a new directory in your home. Right now, you've got probably just like Scratch 10, Scratch 20, Data 10, and Biocomputing, right? Feel free to put anything you want in here. This is your space. You got data for projects or whatever, and it's pretty big storage space, so fine. But I want you to have one called programs. Nice and lowercase. This is where we're going to be installing stuff. We're going to be saving our own scripts that we want to use, like generally for many tasks. Mostly for things that we download, like bioinformatic tools. Hey, here's a paper, and they've got a GitHub repository. We're going to just put it in programs. So make that. And then when I echo my path, you see that I've got my computer searching inside of programs. I've got this little script that I wrote called sinteract. Got FastKey for working with FastQ files. I've got data sets from the InstBI. I've got a couple versions of R and CoFam scan, just a bunch of stuff. I want you to go ahead and copy or move the program we just wrote to do stuff. I want you to put it here into programs. How do I do that from here?
Yeah, you
From home, I was in biocomputing. I was in resources. Inside of that, I was in practice exercises. That's where I found do stuff. I'm going to move it to here or copy it to here. Now I want you to add home/programs to your path. But your path variable, by echo path, you'll notice that they all start from root. It wants absolute paths to search for, not relative. So what is the absolute path from root to programs for me or for you? So I don't expect you to know this. I expect you to figure it out. EWD. Beautiful. So I can just copy that. Export path equals, we're exporting an environment variable. Path equals $path colon the place I was copying. So we've appended a new location onto our path variable. So now if you stick any programs here in this folder, Cyclone Home, your username /programs, anything you put in here that's executable, it'll run from anywhere on the HPC. You could be deep in the bowels of the Kima cluster and type in do stuff and it will run that program. So I'm going to try it. I'm going to go home. And look at that, tab complete worked. just able to type do underscore st and hit tab, and it did it. So it's looking for that program. Now, you want this to be permanent though. You don't want this to vanish the next time you log in and have to retype it. So copy that whole bit, the export path equals dollar path, blah, blah, blah. And where are we gonna add this line?
Your bash, see?
To the bash RC, nano home slash dot bash RC. That magic file. To down at the very bottom of mine, I'm saying like, I'm adding custom paths. Let me put a little comment there for me. Case event. Okay, so I've also got R 4.5 in my path, but just because I stuck it in programs, what? Doesn't mean it can find it there, because the actual executable, the R, when I just type capital R and hit enter, it's in programs R 4.5.0 slash bin, the binary. So path doesn't search recursively through all the directories that you put there. So if I say programs, it'll look in programs for whatever programs I have, but it's not going to look in subdirectories. And so I have to kind of put each one individually if they're on their own. So there's that. Okay, save, exit. Now you've got a directory for programs, is where we're going to be downloading stuff starting real soon. And in there, you're going to change the permissions for things to be executable. And as long as they're in that directory, you can type the name. So anywhere I go, I can run that. All right, lesson 4. We did all this thing. Okay. I'm gonna walk you through how to be more tailored with your chmod music number. So like chmod 755 for the owner, for the group members, and then for others. Read, write, execute is what 7 means. 5 is read and execute, so you can't make changes to the file. So this one's pretty common, like, hey, I own the file, you can read it, you can use it, but you can't change it. Something like that.
What's the order for like the 3 columns? And is it like you?
You, the owner, then people in your group, and then everyone else.
For the group part, do you assign people as group?
Mm-hmm.
Okay.
So or the admins can do that.
Mhm.
I think the command is just groups. Yeah, so I'm members of the applied science faculty and everybody live in Mary Hall. So some files will have permissions that only apply to applied science faculty. I can do that because I'm part of that group. So the admins can do that. What do you guys get when you say groups?
Applied science needs.
Mhm. Okay. Okay, so you got the U for undergrad or user, or I don't know. So you're not an undergrad. It's nice. Oh, you do? Yeah. Okay, well. I don't know what you've done to piss somebody off, but
It's like a.
hopefully it's not a problem. Okay, but I could also make a group. The best way, since this isn't my computer, is for me to contact the admin and say, make me a group for my class. We could all be members, and we could all have permissions that nobody else has. And so that's like Unix admin stuff. You probably don't have to worry about it too much. But definitely keep in mind that you can't run a program unless it's executable. And if you tell somebody else like, oh yeah, here's the path in my program that I wrote, you can use it whenever. They don't have executable privileges and they can't run it. So you just have to go in and do chmod, like, oh yeah, my bad, I forgot. So that'll come up, but that's about it. All right. We got probably time to do this. So go ahead and do it. I don't care if you do this in assignment or not, it's fine. Make a script called first last. Meta file extension. It prints only the first and last lines of standard in.
Do you care if it's like row by row or in columns?
Forgot to specify, so however you want. So I wrote one and I piped history to it. History shows you last N things you've done. And it did it row by row. Where 1,000 things ago, which is the oldest thing, I did LL. And then the most recent was the actual command that I just used. So your script should be able to accept standard input. Here, first and last, head and tail, basically. Standard input. That's stream number one. Sorry, stream zero. Some type file path. Isn't that simple? That on? Yes.
I use like a command substitution, I use like tab. If I'm passing that from one input to another, do I need to like add another? I'm going to add like how do I?
So you wanna like reuse that command substitution?
Yeah, so right now I did it, so it's like. I have it so like I have the first word coming up. But I think like in my logic for the second one, I just have like tap and then type to head -1 all in the command
Okay.
substitution. But then with the tap or tat, I need an input file, right, or an input of some sort.
So you could either do this by making variables
Mhm.
inside your script or using command substitution and caching together those two fake files that we made with command substitution. All right, let's think about it. So let's say I have sour. Where's all right, so I'm in biocomputing and I'm gonna nano test and let's do A, B, C, E, sure, whatever. Okay. So I've got 6 lines there. Just without making a script, what do I need to do to get the first and last test?
Really. And the dash in one, and then tap. Dash head dash in one.
There's how I get the first one. I make that a little file. And then the second one would be cat test. I'm just gonna use tail and one. Real straightforward. Now, how do I do that in a script? Can handle standard in. Here I had to know the name of the file, so the script only works on a file called test. That's pretty stupid. Wow, we're out of time. Well, I'm betting GPT can help walk you through this. You'll learn a thing or two. Yeah.
So when I tried it, like just doing like head within like command substitution works, but then if I do like add, it doesn't. Because I don't have because I don't have anything like running into.
So like this didn't work?
No, that works, but I
Uh-huh.
also like. I can't put in like test into the script, right?
No, you can't put
Yeah.
test into the script.
That's so yeah, so that was like my question.
Yeah. Now, there's an easy way to do it in a script that works on files, not standard input. And this is why a lot of people write their stuff that's like, give me the name of your file.
Mhm.
You're like, no, I'd like to pass you my standard output from this pipeline. And the programmer's like, no, that's harder for me to write. Give me a file name, you dumbass. I'm like, okay, fine. Here, I'm gonna make script.sh or whatever. Shebang, bang, bash. If I take the word test and I'm just like, you know what, I want the user to be able to give me a file name. $1 inside of a script means the first argument to that script. That's it. $2 is the second argument. A lot of bioinformatics software is written this way, where it's like ebstats.sh gives you all the statistical info about your stuff, but then it's like The next thing you need to do is, here's your input file, then your output file. So we're doing that, positional arguments to our script. Save this. Chmod plus X script. Script.sha, and it's like just hung up. It's waiting for me to tell it what to do. Control C. Okay. Script.sha. My test file. Boom. Yeah. So that script took a positional argument, which is what file do you want me to show you the first and last lines of? That's not exactly what I'm wanting from you for this one. I want you to be able to type your standard output to the script. Okay, we are out of time. Do it at home, work through lesson 4, and be ready for quiz and grading your next assignment on Thursday. Then we're going to play more with scripts and start downloading other people's scripts, adding them to our path, and start hopefully really using some genomic data. Paper ready. Yeah.
And for stuff on like the HPC, we have to copy everything to our local computer before we commit it. We can't commit it or push.
From the
We can't
HPC,
push from the HPC.
you can, if you can install the GH program, kind of like you did when we set everything up.
Yeah.
Are you ready for that?
We can try. I can try.
You can try, but that's the next lesson I'm going to walk us all through. Is what I hopefully have gotten you prepped for right now is that you know what your path is, you know how to add places to your path, and you've got wget, so you know how to download shit on the internet instantly. We're going to download the GH. We're going to add it to our path. We're going to use it to like build our password, username, and everything into GitHub. And you can delete it, but that's it. So after next class period, we'll be pushing to GitHub from the HPC. You won't have to copy files back and forth. No, we're like behind on the quiz, so it's more like the stuff we were doing last week. Yeah, file transfer stuff. Yeah. I just looked at it this morning and it was like, I looked at the quiz, I was like, this is too easy. I need to make it harder, but I'm not going to. What I'm saying is that if you can't do it in 5 minutes, there's a fundamental problem with how you're studying. Like, you probably shouldn't be in college. Yeah. You should be capable of transferring files around, making directory files. Yeah.
For the assignment, it says to go with the.
Oh, Aura.
It's too boring.
Aura.
Okay.
I originally had us using Astral, and the APC people were like, we prefer if you had students start with Aura. Yeah.
Okay, gotcha.
I have a question, so I did the do stuff like